Swayam Prabha. Digital India. Educated India.
Hello everyone, welcome to NPTEL course on groundwater hydrology and management. This is week 11, lecture 4. We have been looking at data for understanding the groundwater hydrology in the past weeks. And in this week, we are looking at the other parameters that you can use in the overall groundwater storage water budget to estimate your groundwater levels and management. So in that note, last class we looked at rainfall and how rainfall comes in and goes into your aquifers, because you need water to go in, right? But to understand what is the percentage of rainfall that goes in, we also need to understand how much water is stored across the basin in dams, rivers, etc. So for that, it is very important to understand the surface water storage and river discharge data. Many agencies monitor surface water and rivers, and they could be international, national, and state. And please understand that international, because these big river basins are transboundary in nature, which means the countries are many included in one river basin. For India, let's take the Ganges basin. You know that Ganges starts somewhere in Tibet, China, flows through Nepal, and then goes through India. The Brahmaputra on the other side also comes from the west. Like west parts of your Asian countries. So it comes along the east. For India, it's on the eastern side, and it flows westward, right? The water flows westward, goes into Bangladesh and joins the ocean and seas. So please understand that these boundaries exist. And that is where the agencies differ for each water, river, and storage network, because the water flows and then gets stored in these dams and irrigation projects, correct? So to understand that, it is important to first clarify the differences in who monitors these water storages. It is not one agency alone, there are multiple agencies. And the data has to trickle in from all these agencies to better understand it. So for smaller storage structures, it is okay. We do have data in India or smaller river basins or sub-basins of the bigger basins. And also between states, there are some non-sharing water data because of the sensitivities. So let's take a step back and reiterate. The water storage is happening in large basins, and the large basins come under international category if they are transboundary in nature, if the water flows through multiple countries, at least 2 countries, right? And then they are national level. The whole of India is enough to understand one particular river and its tributaries, for example, the Narmada, Kaveri. But it is also bifurcated as states. The Kaveri basin is one good example, that in Karnataka it is flowing, and also in Tamil Nadu. So the data which is housed in Karnataka part may not be given to the other states and agencies because of the sensitivity. So they claim it as it is sensitive data because it could lead to some misinterpretation and stuff. So that's not released outside. We'll show you how these data are when we look at the WRIS website, just for water storages. Okay, so I'm going to share that screen. on the WRIS page, you will see that I have come to the main page. Okay, because for us, we want to look at all the water data stored in this web page, and we go to surface water. So initially, for groundwater, we went into exploration all these data. Then we looked at hydrometeorological rainfall. We'll also look at ET and soil moisture. But for today, I thought we would first look at storage. So I go to storage and I click MI tanks. So what is MI tanks? These are the minor irrigation tanks. So we understood that when water is stored in these irrigation tanks, water is then released into the land by through channels and canal areas, and that canal areas also recharge groundwater. What you see here is only one state in India has put their data on this website, and that is the Andhra Pradesh data. Okay, so it is clearly saying as soon as I open the web page, automatically it goes to Andhra Pradesh. It says India, Andhra Pradesh. Okay, I did not select a particular state, but because only that data exists, it is going there. And it says around 37,000 or around 38,000 minor irrigation tanks are there from 1 June 2021 to 22 July 2021. And their storage levels are given at a daily time step. And you would see that you have the current year, the last year, and the last 10 years. You could click it to see how the data populates. So see, the last 10 years, the data shows that it is not filling that much, or dam levels are not increasing that much, whereas the year, last year has been a good productive year for the storage. But the current year, the current data, what we are seeing as the highest. Current means this one, the 1st June to 22nd July. And if you come down, all the, how many are there? You could see all these, yeah, all these tanks data is given as a district. So each district has 570, for example, the number of tanks are given and all of them add to 37,974. So in due course of time, I would expect that all states would put their data here, where you have the location of the tanks, and you can also click and go into that. So let's say Srikakulam district. Okay, the district boundary comes up because of the location of the minor tanks. It does take some time to see the district. But what is important is all the total storages are given. If you see closely, sometimes the total storage numbers are same because these are built on a particular size and dimension. So all these minor irrigation tanks are built, and it gives you the data on the storage. It also says 62% full on these average tanks. So for example, all the tanks are taken, their water levels are taken as per their storing capacity, and the percentage is calculated as an average. It says minor tanks data is not available. That is fine, but we can also click on a particular location and a particular tank to see the data. And I wouldn't be surprised if the data doesn't show up readily, because again, this is the only state that has at least put all this location data on the WRS website. Okay, so there it is populated. Let me try one data. Okay, so let's go back to Andhra Pradesh. Let's go back to the first Anantapur district. Yes, so this district comes up, and I hope this is Anantapur district, and all the minor irrigation tanks are put. Maybe because once it takes too much time to load, then please understand that there might be some issues in the network speed also. and you can come here. Okay, the tanks have come. You could see the tanks. You can click on one tank and then see the values of these individual tank values. Right now, what you see is the district tank values, and then you can also download this data for viewing later. See, you have here the data for this tank. The data includes the Sari Kunta is the name of the tank, where it flows. It flows in the Pennan River, Andhra Pradesh, Anantapur district. The location lat long of the minor irrigation tank. The capacity storage is 00. This could be an error because the 50% fill is there. Okay. So this is good data for understanding that if rainfall is happening, not all water can flow and recharge your groundwater, because some water is also stored in these tanks. Okay. You can also change the date and see other time zones, but we will pass this and then go to the storage reservoirs. Before we go to reservoirs, I would like to talk about the reservoir sediment studies. See, when there is sediment in the reservoir, then the recharge potential is also affected, because water on top of the water column, or the water stored in these dams and irrigation structures, are less. So once that water is less, your recharge is also going to be less. Okay. You might create the head, the potential water level can be created and water can be pushed down. However, there is some lack in the recharge. So you have to be careful about that part, how much water is recharging into the aquifer. Okay, so here we have reports of the sediment analysis done. For example, I could just move this to the side, and then you can see here Amaravati. Okay, so I'm just going to click it for Tamil Nadu Kaveri Basin. What you would see is it will populate the data that has been taken as a survey for this water body. And this water body is mapped first, and then you could see the number of years the survey has been done. The last one was done 10 years ago, at least 2013, by the state government agency. The total storage was assessed, cumulative loss of gross capacity. So how much is lost is assessed, and then the sedimentation rate and other things are assessed. So this is important to use the budgets wisely to create these structures as a groundwater recharge structures, remove the sediments, use the sediment in another fashion so that more water can recharge. Still, only less amount of data is in this website, so hopefully it will be getting populated. Please use it. However, see, I do acknowledge that there are some issues in these website in terms of time, space, and resolution. However, this is one of the best data sources available for water resources assessment, especially groundwater resources. So you could be patient and write to them, or go to the state agency and ask for more data in person. And then I'm going to go to the reservoir. Okay, the surface water bodies would just include your lakes, pond locations, and the number of water bodies as classes. So is it greater than 1 hectare, lesser than 1 hectare, how many in a particular state? It's basically a location specific data. Let's take the state, for example. I'm just going to make this smaller so that we can see the location, number of water bodies as per the area. Okay, so as per the area is given, let's say in Andhra Pradesh, we do have all districts, across all districts. This is the total number of water bodies per class. Okay, and you will have the total at the end. You can also download this. We view it as a chart, which does take some time to make. There it goes. So as per the chart, you can see number of water bodies count. So you could see that Chhattisgarh has one of the highest number of water bodies. I'm just going to make this small so that you can see the whole graph. Yeah, so it is the highest, followed by West Bengal. So these are small, but they have the highest number of water bodies. And if you could go into the data, you could see if, what is that water body, okay? What size is the water body? Those kinds you can see. And it does get slowly populated because of the number of data points that is there. And we did see Chhattisgarh and West Bengal having a lot. So I'm just going to go there. And it's still updating, the data on these websites. So there you go. You see all these small, when you zoom in, you could see these small water bodies popping up. And that is what constitutes your data while making these models. Okay. Per district, etc. It's not as friendly as the other websites tab, like here. These tabs, it is not as friendly because they're still populating the data, and hopefully they'll get all these data into the main web page. Now we're going to go to the reservoir data. All I did is water data, and then go to surface water and then reservoir. So I go to water data, surface water, storage, and reservoir. This comes up. So what do you see here is the same default date comes up from 1st June to 30 March 2022. We are having around 138 reservoirs, of which 46% is the full capacity. And because right now also we are nearing the summer period, so there is some water use. Okay. So here, if you have CWC alone, then this is the number of reservoirs monitored. But I'm going to use all agencies so that we also see the state-owned agencies. Okay, still the number is the same, which means all the agencies have been incorporated. And then we are going to look at Maharashtra, for example. So how do you pick Maharashtra? Same the way the data has been arranged. So come down and select Maharashtra. You can select or even type. Let's type it as Maharashtra. So number of large reservoirs are 24 in number. When I zoom in to the state, it goes directly to the map, goes directly to the state. We have 24. So think about it, 138 for all of India, of which 24 are present only in Maharashtra. Similarly, you have the last 10 years data, you have the last year storage data, and the current year storage data, which has been mapped here for the date. So all this does agree that you have good data for reservoir storage at a daily interval. And underneath, you can also see the districts and where the districts are high with the groundwater storage and also the tank storage systems. I'm going to click Pune because Pune has a lot of reservoirs, at least 6 in Pune, and it is highly full compared to the overall average. Overall was what, 48 and 42 percentages respectively. And just in Pune, you see 62%. So the district has been zoomed in when I click Pune, and the reservoir name is here. Okay, so let me click the Koyana Shivaji Sagar dam. Okay, it is live storage is 1.7. The current storage is 1.7 billion cubic meters, which is approximately 64% of the total capacity. Normally, they don't go above 70 to 80 because at that point they have to worry about the safety of the dam and also the downstream communities so that they can release water and not flood them. So you have the last year data, last 10 years data, and then the rainfall, the last 10-year average storage, current storage. So the level is also given in the bottom. So you have the storage on your left axis, and then your right axis has the level in meters. So above this level, it doesn't go up because a full reservoir capacity level is given at around 6, let's say 655. Okay, 657.9 is the total reservoir capacity. Again, it is a default June to March. I'll also change it to show you one water period and how the data goes up. Okay, for the same Shivaji will do. So it gives you more details. The name of the dam, Koyana or Shivaji Sagar. Sometimes these dams have 2-3 names based on the Britishers period, the current period, etc. And it gives you the basin in which this dam is placed, the state, Maharashtra, district, etc. The lat long, which is important. See, now it has actually zoomed in and has selected for us the water dam. And then when was the date? Last date, the data was captured 24th March, which is 7 days before. And we have the full reservoir level is 657.900. So this is the full level as we were talking about, the pink line. Above the pink line, the water need not be stored. So slowly the water is released. Actually, while the water level comes up to that point, slowly water is going to be released because they cannot release it at once, all the water. Okay, so slowly they'll have to release it so that people are not getting affected. So the live capacity is around 2.65 billion cubic meters, and current storage capacity is 1.7 of the total. So for example, 2.67 billion cubic meters is the total volume of the dam, of which the current storage is 1.7. There is still some percentage. That's what 60% is, right? So we do have some percentage. What I'm going to do is I'm going to click on the date, go to Jan, go to 2021, December. See, when you take a full water year with the rainfall, you would understand how the rainfall is generating this runoff and how much runoff goes into the groundwater aquifer. So you can see here the level of the dam is high, goes down, and then starts picking it up again and very high. So this picking up happens after the summer period in June, because until May, June, your groundwater levels, the storage water levels are declining, and after June, when the picks up, the monsoons pick up, then you have more water. Okay, it has gone back to India level again. Let me go back to my analysis state of Maharashtra. I click Maharashtra. This would be much faster than the rainfall data that we looked in the previous class because there is less data points. Okay, so now you could see that this system has been preserved, how the water comes low during the pre-monsoon period, which is the summer, and then during the monsoon it rises and then peaks. Okay, we have all these districts, and as I said, we will go to Satara district, and the dam we want to see is the Bhima Ujjani reservoir. Okay, so here you could see 0, which means there is no water. All the water has been exhausted. So when the summer starts and the pre-monsoon conditions are there, all the water is gone and they release the water. Okay, so if you look at 10 years average and last year average, the storage during these months have been 0, which means all the water has been dried up. And then after the monsoon comes, the water has been captured. So the 90% capacity, etc., has been established. So this is the reservoir. You can see the blue volume represented as a 2D surface. And you have all the other information needed for understanding how the live storage is and can you put more water in it. So 1.52 is the live storage, and it is 100% full in terms of your final data output in this period, because December time, normally the water rainfall stops in September, October, and all the rainfall runoff slowly comes in. and your base flow comes in. This is where it is important of groundwater, because groundwater flow discharge goes into these reservoirs and gets stored. So for example, if the reservoir level is rising, even though there is no rainfall, then please understand that it is the after effects of the rainfall. Most importantly, the water goes into groundwater and then comes back to the reservoir. So with this, I think we have showed how to select one particular reservoir and all the data that is associated with the reservoir. You can also look at the data agency, the data range, and monthly, daily, etc. So I'm just going to click daily to see if it works. You'll have to double check the year. I'm going to do 2020. December 31. So that's one full year I've selected, and the data populates. And if it is blue, it means it is full of with water, that is above 90%. Okay. Again, for some reason, it has to go back to the full India site. I'm just going to quickly run through the Bhima reservoir. Because it is daily, it does take some time. You could see that, see how much data points it has. Okay, number of reservoirs. So I'm going to just go to Maharashtra again. Click Maharashtra. Okay, and then I'm going to click Pune. There are 6 reservoirs. The data is showing up. You could see the blue color coming up with the Koina. I'm just going to click the reservoir to see what is the name and what is the data. So you have clicked Maharashtra. We were looking at the Bhima, so let's look at the Bhima again. So the Bhima data has come up. It is in Satara district. And the data can be downloaded. All the data for that particular daily thing can be downloaded. Sometimes there's a peak. You need to show if there is no rainfall, there's no peak that can happen. So these are the data cleaning that you'll have to do eventually, removing these peaks and outliers. So the locations are given, the live capacity, full capacity, when was the date and time the data was recorded. With this, I'll conclude the surface storage structures for the groundwater assessment. We will see you in the next class. Thank you.